Okay, let's start. Last week I did polynomial function sketching part. Then using quadratic relations we can just sketch quadratic graph. That is parabolic shape now. By using differentiation also we can sketch quadratic graph. And further, for all polynomials we can sketch using differentiation. We have procedure. So the first step, we have to differentiate the function and then we need to factorize it. Thereafter equate that to 0, then find critical value. Therefore that critical value you can substitute to the function, then you can identify the critical point. Okay, then identify that critical points, then by checking sign of dy by dx, then you can analyze the type of the critical point. Then after identifying the critical point, then you find x-intercept, y-intercept, and thereafter you can sketch the function by checking as x goes to infinity cases, no? Terminal limits. Okay, that's the thing. So you have to remember those procedure, then we can completely sketch any function. So further, we have to analyze how to sketch rational type functions. That is very important relation. So for your A level also, there will be rational type functions to sketch. So then today part very important. Definitely for your A level, that rational function sketching will be there. Okay, rational function sketching will be there. Therefore, this is very important and easy part. So we have to consider one thing, that is about asymptotes. There are two types of asymptotes. One is vertical type asymptote and the other one is horizontal type asymptote. Then we have to go only one further step. That's the thing. Okay, that's about rational type functions. Okay, then before that, let's do two questions. Okay, first take this one. Okay, just write. Let fx equal ax cube plus bx square plus cx plus d. Let fx equal ax cube bx square cx plus d. Where a, b, c, d are constants. Where a, b, c, d are constants. And modulus x greater than 1. And f dash x greater than 0 for modulus x greater than 1. Second one, f dash x less than 0 for modulus x less than 0. Modulus x less than 1. Then third one, f1 equal minus 1. Fourth one, f minus 1, 2. And fifth one, f dash 1 equal 0. And sixth one, f dash minus 1 equals 0. So here given f dash x positive for x modulus x greater than 1, f dash x negative for modulus x less than 1 and f1 minus 1, f minus 1 2, f dash 1 0, f dash minus 1 0. Find ABC values, find ABC values, find ABC values and sketch the function, and sketch the function, and sketch the function. Okay. Now this is somewhat special. You have to think little and you can do the thing. Okay, just think and do. Just think and do. Okay. Now here first to analyze. Then last week we did sketching function. No? Then in that case, that initially function has completely described. No? Function has completely described. Then no worry about the function. But here this case, then function not given properly. But some data set given. Yes, data set given. Here function not given properly. You think one by one. Here this is f1 minus 1. So f1 means image of 1. No? Then you can substitute 1. Then f minus 1 2. You can substitute minus 1. Here f dash 1. That means for derivative you can substitute 1. The result will be 0. F dash minus 1 0. Then here derivative 0 cases we call critical values. No? Here derivative 0. Critical cases. Here these are critical value. Therefore 1 and minus 1, 1, x equal 1, x equal minus 1 are critical values. Critical values. Likewise you can identify that. Okay. So anyway, first you substitute these values and try to obtain ABC. Try to obtain ABC. Continue. If you have any doubt, do with me. So now here f1, first differentiate this f dash x, f dash x, f dash x equal 3ax squared 2bx plus c, no? This is the derivative. That is the derivative. Therefore, f1 a plus b plus c plus d, that is given minus 1, say 1. Then f minus 1, here minus a plus b minus c plus d, that is given 2. Then f dash 1, substitute here, 3a minus plus 2b plus c, 0, say 3. Then f dash minus 1, substitute here, 3a minus 2b plus c, 0, here 4. Now we have 4 simultaneous equations, no? 4 simultaneous equations. You solve them first. Then 3 minus 4, 3a cancel, c cancel, 4b, 0, then we get b value 0, b value 0. Then by 1 and 2, 1 plus 2, you can cancel a and you can cancel d, c, then 2b plus 2d equal 1. Then b 0, no? Then d equal half. D equal half. D equal half. Now BD known, take first one, A value still unknown, B value 0, C value still unknown, and D value half, equal minus 1, then A plus C equal minus 3 over 2. Say fifth equation, A plus C minus 3 over 2. Then take fourth one. No, you take, fourth one. Then B value 0, 3a plus C. 3a plus C equals 0. Here sixth one. Now solve simultaneous equation. 6 minus 5. Here 2a. Cancel C. 3 over 2. A value 3/4. Then you go to here, by 6, C value minus 3a, 3/4, that is 9/4, minus 9/4. Therefore, you say now, function fx, a value 3/4, B value 0, then C value minus 9/4, and D value plus half. Here the function. Here the function. Then you can sketch it. You can sketch it, no? Continue. Identify the data set first, then you can go further, no? Okay, now see, here this is somewhat special given data, but without that we can sketch because we know the function now. We know the function now, therefore without knowing this you can go further. But you have to remember this thing, that is, so if you have a relation like this, let's write here, take this one. So if you have modulus inequality like this, here modulus A, say modulus x greater than 1. So x can be positive, x can be negative, both can be positive or negative, x can be negative or positive, both. Therefore, here this meaning, here value 1, then negative value also possible. Then greater than mean that represent here this region and here this region. If we have modulus x greater than or equal 1, here the meaning, you consider number line, here 1, minus 1 and 1. It has included, no, 1 is included. Then greater than mean less than minus 1 and greater than 1. Here the meaning. So if you have modulus x less than 1 mean, modulus x less than 1 mean, here that can include 0, but negative value not included here. But anyway, so if you remove modulus sign, you say that belongs to minus 1 to plus 1 region. Here for this region that is possible. Then modulus x less than or equal 1 meaning, here the meaning, here take minus 1 and plus 1, include minus 1 and 1. So within this region that represent minus 1 to plus 1 region with include, no? Here not included 1 and minus 1. Here other regions. Okay, you have to remember that. That is very important thing. So modulus x greater than 1 mean greater than 1 less than minus 1. Modulus x greater than or equal 1 mean greater than or equal 1 less than or equal minus 1. Then modulus x less than 1 mean within this region. And here with equal, then here the value. Okay, you better note it. You better note it. See this, here derivative positive for modulus x greater than 1. Here derivative negative for modulus x less than 1. Okay, then sign of the derivative has given. Sign of the derivative has given. So now we can sketch a table. No? So you consider f dash x sign, f dash x sign. So here minus 1, minus 1, plus 1, plus 1. Here the region. No? And modulus x less than 1 mean, modulus x greater than 1 mean, here the region. So in that case that is given positive, derivative positive. And here modulus x less than 1 region, here this one negative. Then plus to minus maximum, minus to plus minimum, minus to plus minimum. Okay. Then here we have critical values. Here 1 minus 1 critical value, then corresponding y values again given, corresponding y values are given. Therefore, we can identify critical point. Here 1 minus 1 critical point, minus 1 2 critical point. Then here coordinate minus 1 1 minus 1, here minus 1 2. Since 1 minus 1 critical values, you say here these two are critical points. You say these two are critical points. Okay. Then here this critical point minus 1 2 local maximum, then 1 minus 1 local minimum. Here local maximum and local minimum. Now here we have the function. Then by this one you can check terminal limits. So fx, you take maximum power term outside, that is x cube. Then 3/4, 9/4 x, 9/4 1 over x squared, 1 over 2 x squared. Then when x goes to plus infinity, y goes to plus infinity. Here these two are zeros, no? Here x cube, and here plus infinity. X goes to minus infinity, y goes to minus infinity. These two are 0, here minus infinity. Okay. Now we can complete the graph. We know here x, y, critical point minus 1 2. Here minus 1 2. Take that one as local maximum. Then the other one 1 minus 1. Here 1 minus 1. That is local minimum. So now we know the function. Here. Then y-intercept will be half. No? Therefore, you complete the graph now. Y-intercept you mark as half. Therefore, here you sketch. Then here this intercept is half, and complete. Here the final graph. Complete it. Then here this function not given properly, then using the given properties, we have to identify the function and we have to sketch the function. So previous day I did sketching function, full detail given, that means function completely given. Then we can go step by step, but here this case we have to consider the given properties, then we have to identify the function, then we can proceed, no? Okay, complete it.